country, and hopefully this will keep your mind off of it for a few minutes. But what we always like to do is supply our customers and associates with just the latest information that's happening out in the marketplace. And as you know, the electrification of vehicles is becoming more and more popular, gaining momentum, and we believe that this is going to be the future of transportation at some point. So we've lined up one of our valuable vendor partners. We've got Jason Geese and Joe Sontag from Navistar that's going to give information on some of their latest developments that have coming on in their industry here, and it's going to be some really good, valuable information. And AIM as a provider of transportation solutions, if there's anything that we can do in these trying times to help with extra vehicles, we've got an integrated division that has drivers. Anything that we could do to help support your business and company, don't hesitate to just reach out to me personally, and I can guide you in the direction where we can be maximum benefit for you and your company. So at this point, I'd like to introduce Jason, and Jason, the floor is yours.
Thanks, Matt. I appreciate the introduction. Yeah, we're going to just kind of go over what Navistar is doing on the electrification front. I'm sharing a presentation on the webinar right now, so please follow along. Be glad to take questions throughout. So if you'd like to pause me, I can take some questions, or we can wait till the end too. It doesn't matter. So let's go ahead and get started since we have about an hour, and let's go. So what is next? So Navistar has taken a huge commitment on the electrification front in the last 12 to 18 months. What we've been able to do as a company is create a new business unit and team that is dedicated 100% to electrification. The team is going to be housed in a technical center in Rochester Hills, Michigan. And we're going to be focusing on electrifying Navistar's vehicles. It doesn't mean we're completely seceding from Navistar. We're working hand in hand with the folks in Lisle on a daily basis. We're not going to go out and design a brand new vehicle from scratch. We're going to continue to build on our platforms that our customers know and love today. But we are going to make a purpose-built electric chassis and platform to grow that in this space. One of the other areas of focus is where we're going to be making these. One of our goals is to build in Navistar's manufacturing facilities. So the school buses will be built in Tulsa. The trucks will be built in our truck plants. And with the only exception to that being our initial chassis will be built with our sister facility in West Point, Mississippi with Navistar Defense, since they're used to building at lower volumes. Okay. So a little bit about our technical center. I was over there yesterday. They're carpeting and putting ceiling tiles up, so we're about the 95% mark on this. Really, this is going to be a facility where we can bring customers, show a little peek into what we're doing, let the customers see the vehicles, discuss things around the vehicles such as charging and infrastructure, and work hand in hand with our team members to focus on this space. So what we're doing here, we're emphasizing these areas that I have in the left column, really like power electronics, controls is a huge one, charging infrastructure, and then just really analysis of the vehicle and the systems. Why is Navistar doing this? A lot of folks have asked. We're doing this to be near engineering talent that have worked on electric vehicles in the past. We are growing a team right now. A lot of our folks have come from the big three automakers. A lot of them have come from tier ones that have worked on major electric vehicle programs in the past. So we're excited about watching the team come together and work on these new projects. The other reason is we're near critical suppliers and real focused testing facilities for electrification. Okay. So what are we focusing on at Navistar today? So really our current initiatives are in the center here. And so what this chart illustrates is the vehicle sales by type in the commercial vehicle market today. The electric commercial bus market is converting rapidly to electrification. They're seeing what we're seeing, or they have been seeing what we're seeing now for about 5 years, a huge growth curve. The gentleman who runs the next business unit, his name is Gary Horvat. He was the CTO of Proterra. They were a startup. They are a startup in California. He was the CTO during all of their growth. So when he started 5-6 years ago, they were making a handful of buses, roughly 5 to 10. Now they're in the hundreds of buses a year, and they've seen the transit area spike. But the volumes are very low in that space. So where we're starting to focus, of course, is in the middle here. So IC bus and our commercial international medium-duty trucks. We see larger scale on-highway a future development where we have some plans for that, but that's not our initial goals. So the next product roadmap is fairly simple right now. We're focusing on school buses today and shortly thereafter medium-duty trucks. One advantage that Navistar does have in international is that our chassis are very similar from school bus to truck. So the development we're doing on the school bus translates mostly to the truck. There'll be some minor changes, but for the majority of it, powertrains, batteries will translate over. All of our controls work will translate over. So it's an exciting time. Right now we're building some buses. This timeline's actually getting slightly delayed due to what's going on around us, but we're trying to get these vehicles completed here and on test immediately. Our initial customer bus pilot deliveries will be late this year, and then we're hoping to do similar deliveries early next year with our truck customers. We do have a truck running around. It's been at a few of the shows. It was debuted at NACV last year, and we had that work truck last week or 2 weeks ago now, I suppose. It is running and driving. We can't have customers and drive it in a parking lot or on a test track at this point. And then a future program is our e-tractor program, and I'll get into that a little bit more in the future, but we're not really saying this is a RH or an MV tractor. It's kind of a hybrid approach to it, and I'll discuss that momentarily. Okay. Some of the vehicle highlights that International is focusing on right now are these following items. The first one's AC and DC charging, so we're having combo charging on it. Some of our competition, especially in the school bus space, has chosen to go one or the other direction. There's issues if you only go AC, you can't fast charge. But it's cheaper. If you go DC, you can fast charge, but it's more expensive up front. So we've chosen to go both directions on all of the vehicles we're creating. We're also offering vehicle to grid on everything we produce too, and I'll get into that more in an upcoming slide of what exactly that is. We're also going to give our typical access to our dealer networks. We've got one of the largest dealer networks in the world or in the country, and we're going to continue to utilize that. Right now we're launching simple, I would say, applications, so box trucks, flatbeds, limited PTO type of specs, but we will be adapting to other solutions in the future. We're already in talks with some of the large refrigerator body makers or unit makers, right, on implementing their designs, and then some of the large body builders for other types of things. And the last point here is functional safety. So this is a very important one in our minds. We at International and Next are working to certify the vehicles at a automotive level functional safety certification, which is ISO 26262. This has typically been a certification only held for automotive. Recently, they've opened expanded the certification to commercial vehicles. It's not mandatory, but we will be utilizing it as we develop to make sure our vehicles have the functional safety that an automotive passenger car would, and making sure that our passengers and, of course, especially on school bus, the children are safe. Okay. The other thing that we find as important, or sometimes even more important in the vehicle, especially up front with our customers, are we're calling the 4 C's. So we're going to run through these here, but we find this to be a huge advantage actually over some of the things our competition's doing, and just helping our customers have the peace of mind how they're going to implement these vehicles. So the first one here is consulting. So what we're doing with the consulting C is route simulation, number 1. So as the customers come to us and say, we want to put a vehicle into this space, we can go out and take some of the worst case routes, process them through our system. We can do it on the coldest day, the hottest day, the median average temperature day. And we can do, if there's a PTO on it, include a number of PTO uses, and we can model different driver behavior and things like that to show, will this vehicle actually be able to be a success on these types of routes. The second area of consulting is charging. So it kind of bakes in with the third C is, as customers come online, one of the biggest questions we receive almost every day is, how do I charge these things, and how much is it going to cost, and what is that going to look like? So if you decide to move forward with an international truck as a customer, what we'll do is a remote site assessment, which entails roughly 5 to 10 questions, depending on what we're doing, basically asking how many vehicles you're planning on buying immediately, what's your plan over the next 5, let's say 10 years looks like on vehicle purchases, then asking you some simple questions about facilities. What is the incoming power? Can you take a picture of your panel? Can you take a picture of where you would potentially park these vehicles? What we can do then is we have some tools that we can do a remote site assessment and basically put a 95% of proposal, what we call it, in front of you. We'll show you roughly what it will cost, roughly what it would take from the infrastructure side, so the power provider side, and then roughly what it would take from the infrastructure side for on-site. And we can do other things like recommend, if you're only going out for 1 shift a day, maybe we put in X amount of AC chargers to start. If we grow the fleets over a certain size, we would look at doing a DC charger over a certain amount of years. We can grow the plan. So basically give you a 5 to 10 year capital expenditure plan on outfitting the different facilities. Okay. The second C is constructing. We touched on this earlier, is we will be building in Navistar facilities. We see this as a huge key. We're a large truck manufacturer today. It's a key for us. And this is where I think some of the startups are struggling today is actually scaling. We will be able to scale in our facilities. And then back to the third C is the charging piece. We will also offer multiple different kinds of charger hardware, AC chargers, DC chargers. So we can make sure we right size the installation for our customers. The other piece of the charging is on the grants. There's plenty of grants for both the vehicle and the charging, so we work with that as we do installations. And last is the fourth C is the connecting C. We will be implementing a upgraded international 360 service with the electric vehicles, which will include a lot of other pieces, and I'll get into that in a future slide, a little bit better outline. Okay. Let's talk about charging fundamentals for a second. I know I've been throwing out for folks that are new to electric vehicles. This goes for passenger car and for truck too, so it's pretty simple. So we're going to be offering AC charging and DC charging. So AC level 1 charging is basically your wall plug today. We typically wouldn't recommend using that for a commercial vehicle unless it was an emergency. The charge times will be just way too high. AC level 2 charging, that's the plug, of course, behind your stove or your dryer, 208 or 240. That is pretty much the standard today for most passenger cars when you put them into your home charging environment, or even commercial charging environments for Teslas and Chevy Bolts, etc. So that charging standard charges up to 19.2 kilowatts. Typically, though, if you see them on the side of a hotel or something, or side of a business, it's usually in the 7.7 kilowatt range before you have to do anything special. So you can get roughly 10 to 20 miles at charging rate per hour, depending on what AC level 2 charger. Okay. And then getting into DC fast charging, this is a rapidly growing space right now. Typically specialized, quite a bit more expensive. So roughly, and each installation is differently, but an AC level 2 automotive charger you can get for a couple of $1,000s today, a portable one. One that we would recommend for commercial use, you're probably talking between $4,000 and $5,000. That'll include some level of connectivity. DC fast chargers typically start no less than $20,000 today, unless you get something out of China that we wouldn't be comfortable using. And they can go up into the hundreds of thousands of dollars depending on what size. And if we wanted to do a whole separate thing on charging, I would be glad to bring in one of my charging specialists in the future, and we can have this type of, we can go through all the different types of systems that you can put in, anything from single port usage to multi-port, multi-stock, large box systems. So we can do that in the future. But we have all those as an available thing as we grow. We don't expect our customers to spend, unless they're buying hundreds of trucks to start, we don't expect our customers to spend hundreds to millions of dollars on charging today. So back to the fundamental piece of it though. So the DC fast charging, we can charge right around 125 kilowatts with the DC fast charging on our current vehicle today. That doesn't, is without any kind of liquid cooled cables and things like that. So to put in perspective, that's right around where Teslas charge today. The fastest charging vehicle, and it hasn't been done yet, I don't think publicly, is the new Porsche that's coming out, and that'll charge at 350, but that's including liquid cables. And that vehicle was purposely designed at a higher voltage rating so it could have a faster charge rate. So we're using production representative components. So, and pretty much the standard for what commercial trucks are going to be, what we think in the near term, at the 600 volt rating on our vehicle, which, like I said, gives us 125 kilowatt charge rate. Okay. Oh, one thing I apologize, I skipped over, is we're using a J1772 combo CCS1 charger. Same charger that's on the Chevys, Volkswagen, the new Ford that's coming out, pretty much a North American standard. And I believe, not to speak for our competition, but I believe all of our competition's using the same charging port, including potentially Tesla on their truck. Jumping back into connecting, so if you're familiar with our 360, it gives diagnostics out to fleet managers, dealers, all the way down to the driver today. But we are going to be adding to this platform. So some of the things we're going to be adding is charging on the charging side. So simple things like, is the vehicle plugged in? We want to give our fleet managers that kind of peace of mind that he knows that when he goes to bed at night, all of his vehicles are plugged in and charging. We'll also give him feedback of if it's a multi-shift type of operation, this vehicle takes X amount of time to come to a complete charge and can go back out. So he can see where each vehicle's parked in his lot to to prepare the vehicles to go back out of the out to do their job. So like I said, we'll have state of charge. Other things we can monitor is driver behavior, how the vehicles are being maintained, of course, that we do today, but we'll have added vehicle diagnostics for the electric vehicle portion of it. Okay. Let's talk about vehicle to grid and vehicle to building. So V to B and V to G. Pretty simple concept, but you're hearing a lot, and a lot of folks are saying, "Oh, we can do this today." You can do it in a test stand today, but I don't believe anyone's really doing it whole with multiple vehicles working with a power company. We are working with multiple vendors that are on both the chargers and on the connectivity side that are working on this today, and we expect to have it on our vehicles within the next 12 to 24 months. One thing we will have is every vehicle that we produce today will have the hardware that will allow it to, the hardware and software that will allow it to do it as it comes online. So essentially what this is you can have a mobile power plant. So where this really is an interesting place is in our school bus side. School buses typically sit most of the summer. A lot of our customers are already planning on plugging them in and being able to feed power back into the grid throughout the summer. And essentially you can turn a school bus yard into a small peaker power plant. So the way it works on the power flow side in the top portion of this display here is the vehicle is plugged back into the charging station. The charging station takes DC power back in through the cabinet, and then the cabinet takes the DC, converts it back to 480 AC, which pushes it back into the building. We can leave it at just that. One of the things we will be demonstrating at our facility in Rochester Hills is that we'll be able to power a portion of our building off of the vehicles. Taking it one step further than that, you could push it back into the power companies. Like I said, a lot of the power companies are working on this today, and it'll be online probably within the next 12 to 24 months, at least in the pilot stage. The communication flow is a much more complicated thing, and that's where a lot of the focus is at today. Okay. A lot of folks have asked about Traytime, so I always leave this slide in here. At Navistar, it has been a huge advantage to have Traytime on our side. It was announced at NACV last year during the press conference that we've had a $500 million goal in 5 years to get joint costs out of our systems through a purchasing agreement. I believe we're about halfway through that, and we were a little over $250 million when they spoke at NACV. So that's been great for Navistar as a company. Where it's really helped our electrification team is Traytime has announced publicly that we're putting $1 billion in the next few years into electrification. So we are able to leverage that. One area of immediate help has been in our batteries. So the battery we've chosen for both the truck and the bus program is the same battery that Traytime's using with Volkswagen Brazil and on some vehicles that they're building in Europe that haven't been announced. This gives us a huge economies of scale right out of the get-go, which is a big help to get some costs out of our vehicles, out of the initial trucks we're building. Future plans, Traytime is working on future technologies all through electrification, and we're seeing a lot of gains on future planning on electric auxiliaries, potential batteries, and potential drive systems. So there'll be an exciting future with us together. Okay. Let's talk about the truck for a second. We've been talking about a lot of the ancillaries. So this is the truck we debuted at NACV last year. It's our EMV. We've been calling it a concept, but it's more of a look into the future. So it's a lot of concept components on it and designs, but it does show a glimpse into our production batteries, production drive system, and how we're going to launch the vehicle. The hood's concept on it, I don't believe we're going to go to market with this hood. It was just something to show some of the things we could potentially do in the future. A little bit about the vehicle. We've got 3 battery capacity options. The first one's 107, 214, and 321. The ranges on them will be roughly 70, and these are nominal, with some level of parasitic loss, so heating and air conditioning. So 70 for the 107, 135 for the 214, and right around 200 to 205 for the 321. Those are pretty conservative numbers, we think, and it'll cover the majority of duty cycles. Now, in extreme cold areas, there will be losses. I think that's pretty much common across the board with any electric vehicles. But we do have heated and cooled batteries on the vehicles. So our recommendation for customers is keep it plugged in if you're in cold areas and you expect to drive it the next morning. We'll do things with the controls to precondition the batteries. We can precondition the temperature in the cab for both hot and cold to help take that initial loss off the vehicle. On the performance side, we're going to have plenty of performance on this thing. A lot of customers are like, why are you putting so much horsepower into this? It's not really for the drive side. A lot of it has to do with the regenerative braking side. So we want to be able to put as much power back into the batteries as possible. So on the drive side, we're going to give customers the same control that they have today. If they want to govern down the truck to drive just like a diesel, we could do that today. We expect the performance to be substantially better, especially when merging into traffic, but these are things that we can adjust all through controls. Okay. So how did we get to our ranges? We did some studies over the last few years and took some of our on-command connect data. We took 4,500 trucks last year and took the averages of what their daily routes look like. And as you can see by this chart, the majority of them are under 200 and really under 150. So our focus was to build a truck that could do around 200 miles, but really the sweet spot between 100 and 150 miles. So that's why if we go back one slide here, the 214 kilowatt battery is where we think a lot of our customers will buy, just for cost reasons and for route reasons. Quick slide on grants. So wherever the vehicles are going, we always encourage, and we'll have team members on my team that can help out with this. Look for grants. There's always grants all the way down to even some of the cities. We met with a fairly major city in Wisconsin a couple months ago, and the gentleman that we met with said, yeah, I'm getting funds right from the city to fund some electric vehicles. So make sure you, as you're looking to buy these vehicles, check all the way down to those levels. There's Volkswagen money out there. California has probably 6 or 7 different programs right now that are active. New York, like I have on here, has the TVET program. That just came online late last year, and there's a substantial amount of money out there for these initial purchases. Our goal as Navistar, though, is not to rely on grant funding. We will need it in the low volume times just because of volumes and ramping up, but our goal is to be at total cost of ownership parity or better as soon as possible. We are at total cost of ownership parity today on some of the school bus programs we're running, but a lot of it depends on a couple of things. Your current fuel price, what your current electric prices are, what you can negotiate, and then your miles driven. So we put those into our calculation tools, and we can show you where we think roughly your break-even point is going to be for the life of the vehicle. Okay. One future program is our e-tractor, and like I mentioned earlier, we were calling this an EMV or an ERH tractor, and it was actually getting our internal folks confused. Really, the program goal here is to create the most compact electrified tractor in the industry. So if you're familiar with our vehicles of past, the 4400 4x2 or 6x2 small tractor. Now, a lot has changed over the years. That truck isn't as popular just due to engine options. Well, we don't have that problem on the electrification side. So the goal with this vehicle would be to create a truck that can tow 60,000 pounds in a 6x2 application, or even in a 4x2 application pulling a tandem trailer. Real short cab, very compact battery. So we're doing some analysis on this today with our team. We want to have a vehicle that can get into city centers. We've had a lot of customers tell us that, hey, what we're seeing from your competition out there today is just too big. It doesn't work for city center applications. It doesn't work for going into, let's say, San Francisco, LA, places like that, that will start outlawing IC engines sooner than later. So some of the differentiating technologies we're working on is some e-axle for performance and packaging, and then higher density battery packages that are purposely designed for these vehicles. On both the school bus and the truck, we're using an off-the-shelf battery, and it works great. It fits between our frame rails. It's got a high level of safety. It comes with its own battery management system, so we're comfortable with it. But when you get into these tougher applications, you have to do a custom-built battery, so we have a team working on that today. And then, like I mentioned earlier, through Traytime and through some of our internal folks, we're working on some of the latest auxiliary technology. If you look at what some of the initial adopter companies were doing, they would do a electric belt drive that drives the same systems they have today, power steering, compressors, things like that. That was a step in the right direction, but that's not the most efficient system. So putting it all together as the most efficient system will get you the best gains, and you can see it today in automotive. Tesla has some of the best efficiency out there just because they've been doing it and they understand the controls piece and how to put it together better. That's going to be that's one of our goals as a team here as the next eMobility unit. Okay. Last slide I have before we want to take questions, and like I said, we can jump around and answer those after this. So, are some service and maintenance considerations. So, we're putting together some folks on my team right now that'll be out training our initial customers and sites and dealers for high voltage and lockouts and anything that's specific for the electric components. Another thing to consider is there will be minimum preventative maintenance on these new vehicles. We have liquid-cooled batteries, liquid-cooled motors, so glycol will be on board. There'll be a radiator to cool those things. But the only oil actually on this vehicle is going to be the differential oil that's in the axle that we have today. Even when we go to an e-axle type architecture in the future, really there's only going to be transmission fluid in those. And I know a lot of the suppliers that are working on them are looking for 750,000 plus on the maintenance cycle. So very, very little maintenance on the traditional type of components. Tires could require extra maintenance. I always like to throw that out there. I think you're seeing that in passenger cars today. Full torque at 0 RPMs is not as great for tires. And the other area you'll see tires is the regenerative braking. They typically weren't designed for that much reverse loading. But I know for a fact that many of the large tire companies are starting to work on this problem and should have some solutions in the coming years. Vehicle body and interior maintenance won't be impacted. If you jumped in the truck at any of the shows that you saw, it's the same vehicle we essentially built today. The only difference you'll really see inside the cab is we're doing a digital cluster, which will give you a lot of feedback on battery performance, things like that. Another area of maintenance is we will be handling battery and drivetrain maintenance. We expect very little issues with the drivetrain side of it. They're pretty simple. Same thing with the batteries, but we will have plans for if a battery starts showing any kind of an issue, we'll have a swap out program that'll be, our goal is to have batteries to our dealers within 24 to 48 hours, depending on location, to swap out to make sure the vehicles stay on the road. And then, again, the ISO 2626 standard, this carries into functional safety on making sure that our technicians know that the vehicle's powered down, make sure that they have lockouts and those things are all accounted for whatever areas they're working on. So we're taking those in consideration as we're architecting the vehicle right now. Okay. And that is all I have. Questions?
Any questions for Jason? Feel free to either unmute yourself and say your question verbally. If you just click on that mute button in the bottom left-hand corner, you can speak, or you can type it out in the chat function.
Hey, Jason, on the straight truck model, how soon do you think realistically there would be something that would be available for market?
So we'll have some, our goal is to have in first quarter and the second quarter of next year. With everything that's going on, I'm saying second quarter to third quarter now, just due to everything, the world today. But that's for select customers. So we're probably going to have, I would say, 50 to 100 vehicles on the road sometime middle of next year is our goal.
And with the ranges, are there going to be variable range models you can get, or are they all pretty much going to be at the 100 to 150 miles?
We're gonna offer the up to 150 miles to start. And let me jump back to that slide real quick. It's easier to explain. The 321, and I put an asterisk by it, is depending on chassis, it becomes a packaging challenge, especially between the frame rails. And depending on body, it becomes a challenge if we put it outside of the frame rails. So we have to look at each application for that.
Any other questions for Jason? All right, well, I just want to thank you very much, Jason, for hosting our webinar today. To everyone that's on the call, I will send out a link to the video with some supplemental information, Jason's contact information, my contact information, and a link to this video if you guys would like to revisit it or share it with anyone in your organization. I just want to thank you again for your time and remind you that you know, electrification is coming and AIM wants to support you through that transition. We're, you know, working towards the future just like you. And as everything's happening today, as Matt stated, we're definitely here to meet the changing focus and the changing needs of your company. So let us know what your pain is in everything that's happening in the country and world right now. And hopefully there's a way that AIM can help out. We have a lot of rental availability and different solutions we can kind of bring to you to make things run a little more smoothly for you. Matt, do you have anything else you wanted to add?
No, I just want to thank everybody for their time. I know everybody's must have a lot going on in their businesses, and appreciate you taking a couple of minutes. And again, to reiterate what Jess said, if there's anything we can do to support you, please don't hesitate to reach out to us personally. And thank you.
Thanks, Jason.
Thanks,
Thank you,
guys.
Joe.
Yep, thank you for the time.
Thanks, Jess.
Thanks, guys. We'll catch up with you soon. Bye, everyone. Have